Hello viewers, welcome to my channel Life's Calculations. Today I am going to discuss the graphical representation of continuous frequency distribution. Okay, you know we have got a number of ways of graphically representing a numerical data, right? In very junior classes we start this process and if you remember you have already done the plotting of bar graphs. Bar graphs also very simple way of showing any data on the graph paper, okay, analyzing and interpreting with the help of graph paper. All of you have done already. Okay, now there is one more way, rather we have got 2-3 ways of a graphical representation of the data, and from those 2-3 ways I am going to discuss here the way of plotting a histogram, right? Histogram, this is a new word, maybe new word for many. Okay, so please see carefully how is it done. So let's get started. Here students, for plotting the histogram I have taken up a continuous frequency distribution table for you. Okay, so what is the meaning of this continuous frequency distribution? First of all, right, we are given here the class intervals, and against those class intervals he has given us the frequency, right? So first class interval here given is 0 to 10, second is 10 to 20, 20 to 30, 30 to 40 and 40 to 50. Okay, in each class interval we have got a lower limit and an upper limit. Here also lower limit, upper limit, lower limit, upper limit. Okay, so it is very much important to see that at the time of plotting a histogram, right, our data should be continuous. The class intervals should be continuous. Okay, and here I can show you one more word which can be used, right? That one more word is that the data should be exclusive. The data should be exclusive. This is the most important word. Okay, data should be exclusive. Now what does this mean? Okay, so we will check with the class intervals. This is the upper limit of the first class interval. Okay, and again just see this upper limit of the first class interval and the lower limit of the second class interval are coinciding. Coinciding means the upper limit of first and the lower limit of the second class interval are exactly same. The process has been repeated. The upper limit of the second is the same as the lower limit of the third, right? And the same thing, like the 1/3 class interval finishes at 30, but the next fourth one is starting at 30 only. Means where one finishes, the next one starts at that point only. This is the meaning of continuous frequency distribution, or this is the meaning of being the data in the exclusive form. Exclusive form. Once we have made sure that the data is properly given in the exclusive form or it is continuous frequency distribution, we can very well start with the plotting of the histogram, right? So students, now we are going to start the process of plotting a histogram, right? For that, what you need, first of all, you need a graph paper, you need a pencil, and then you need a scale, right? Only with the help of a pencil and scale any graph is drawn. Never use a pen either to draw or to write anything to plot, anything to write, lines, numbers, digits, anything to be written on the graph paper is always written with the help of a pencil. And one more important thing, at the top of the page all of you are always required to write on one side of the paper. All of you should always write the question number or the answer number. Okay, every time, whether in the exam or in the normal classwork copy only. Okay, so now what we will do here is just like our bar graph only, just like our bar graph only, we will plot two perpendicular lines. One horizontal line I have drawn here and one vertical line I have drawn here, which all of you know is not, this is not a new thing for you, okay, because earlier too you have been drawing the graphs. Okay, now once that horizontal line and vertical line have been drawn, we are going to show the origin. Origin is the point. It is always written with the help of point O. Origin is the point where both this horizontal as well as the vertical line meet each other, right? So this is the origin. Then another thing, the horizontal line is known as x-axis. We are going to show it like this. X-axis we are going to write, and the vertical line is known as y-axis. So on the top I should write on the top as a y-axis. Next important thing is to decide what is the scale to be used before we start plotting the histogram, right? So it is up to you now, right? Scale you have to draw according to the availability of the space or according to the question given, right? So question given to us was that we have to plot the histogram for this class interval, this frequency distribution class interval. First is 0 to 10, 10 to 20. On this side we are going to go up to 50, from 0 to 50, and on the other line, on the other axis, we should plot the frequency. Frequency, we have to see the minimum value and the maximum value. Minimum value here given is 6 and the maximum value given is 15. 6 to 15 we have to plot, and on the other line we have to plot from 0 to 50. Let us talk about the first box first row first, right? First row is about class intervals. So remember, class intervals are always taken along x-axis. They are always taken along x-axis, and the frequency is taken along y-axis. Remember, right? So 0, we have to start the x-axis. Class intervals from 0, 0 means the origin only. Okay, so first thing to be seen, that first point will lie on the 0 means origin. Then next should be 10. Next should be 20, next should be 30, 40 to 50. Okay, so if this is so, then here I will show that this side you have to plot properly, that this side you are going to take the class intervals. I have written here. Okay, and the other side, this x is extra, I will remove this, right? On the horizontal side or x-axis side, I am going to plot the class intervals, and on vertical side or y-axis side, what I will plot, that is called as a frequency. So I will write it as a frequency, right? Second thing is, I have plotted here 0, then next was 10, 20, 30. This box, complete box, I am going to leave here. The dark lines only are shown. Dark lines only are plotted. Okay, shown dark lines. So next is 10, next gap is after a gap of 10 I have plotted 20, after a gap of again 10 small lines, 30, 40 and 50. See the constant or the uniform gap between one box I have left, then I have marked these point, one box, then I have plotted only on the dark lines, right? So this will help us in writing the scale. Very important, before you start any graph work, always you should decide the scale first. I have given the heading here, scale. Remember, scale to be written on always on the graph sheet only, and I will write here as on x-axis. Okay, on x-axis what will be the scale, that 1 unit, this is known as 1 unit. Actually this 1 unit is equal to our 1 centimeter, is equal to our 1 centimeter. Okay, so I can simply write it as, on x-axis 1 centimeter is equal to how much? It is equal to 0 to 10, 10 to 20. Everywhere there is a gap of 10, 10 only. So I will write 1 centimeter is equal to 10 units. Right, 10 units. Why I am writing the word units here? Because nothing goes with the class interval. These are simple numbers only. It can be anything. Okay, this can be marks also, weight, marks, wages, anything. So I will, because not specifically written, so I will write it as 10 units. 1 centimeter is equal to 10 units. Same kind of scale I am going to decide on the y-axis side also. Okay, so now what will go on y-axis? See, on y-axis we were supposed to take what? We were supposed to take the frequency only, where the minimum value is 6 and the maximum is 15. So maximum value is not quite much. Okay, so it is within range only. So what I have done, it is again your choice. You can decide the scale according to the availability of the space or availability of the given numbers, right? So because the numbers are simple 1 2 3 4 5 6 7 8 within up to 15 only. So what I will do, I have taken up here from 0, I have taken up 1 2 3 4 5 6 7 8 9 10 and up to how, where I have gone, I have gone up to 15 here, right? Keeping leaving each box, okay, and then writing 1 after every box. I have taken a gap of 1 so from origin this is 1 2 3 4 5 6 up to 15 I have gone, right? So what should be the scale here, that on y axis 1 centimeter, because this one box is equal to 1 centimeter only. So 1 centimeter is equal to 1 unit. From where this 1 unit has come? What is the difference between 2 to 1? 1 only. What is the difference between 3 to 2? It is 1 only, right? So common scale should be followed, okay, for a particular axis. But for x-axis and y-axis it can be different. Here it is different only. On x-axis and y-axis I have taken up a totally different scales that can be there, right? Now let us start with the first thing to be plotted. First class interval should be plotted against first frequency. This should be the set. Our first set to be plotted is 0 to 10 on where? On x-axis, okay? On which axis? On x-axis, and 7 should be plotted on the y-axis, remember, okay? 0 to 10 and up to 7. Okay, now just see how to start, like here. 0 to 10, 0 is here, 10 is here, है ना? And from 0 to 10 we have to go up to where? We have to go up to 7 on y-axis, 7 on y-axis. So what I will start, I will do from 0 to 7, already line has been drawn, and I will draw one more line from 10 to 7. From 10 to 7, this was my 10, okay? I will take up a transparent scale. Up to 7 I have to plot, right? So 10 to 7, this is the straight line I have drawn. Remember, line always should go only on the dark lines, right? So then I will join this like this, like this. How? I will read it as from 0 to 10, 0 to 10 I will go like this, and where I will stop? I will stop at 7. 0 to 10 on x-axis and up to 7 on y-axis. So here, just for clarity, you can write here as 7 also. Okay. So this is our first rectangular bar for the histogram, right? After 0 to 10 has been plotted against 7, next is 10 to 20 to be plotted against 12. 10 to 12, 10 to 20 to be plotted against 12. See, from 10, now this is the meaning of being exclusive. We finished first rectangle at 10 and the second rectangle is going to start at 10 only, right? So, from 10 to 20, we have to plot 12. So, first of all, I will plot a vertical line from 10 up to where? Up to 12. So half of the line is already drawn. I will simply extend it up to 12. Okay. Now 12 is there on the top. So I will draw like this. So up to where I have gone? I have gone up to 12. Okay. Then again I have to draw. See, from 20 one more vertical line I need to draw. Okay. So the process is same like bar graph only. Now students, after plotting the exclusive form of the data in the form of a histogram, now I am going to tell you how to plot the histogram when the data is in inclusive form. Okay, now I will tell you here only that what is the meaning of inclusive form. Okay, inclusive. I have taken up a different example for that. That was the exclusive form. Now I have taken up inclusive form, right? So what is the meaning? Here again the same things will be given to us, class interval and frequency. Now see the class intervals here: 10 to 14, 15 to 19, 20 to 24, 25 to 29 and 30 to 34, right? So now what is the problem here? Problem here is that this is data is not continuous. Means unlike the previous example where one finishes, the other does not start from the same point. Where one finishes, the other does not start from the same point. This is the meaning of being inclusive. This is the meaning of being the data discontinuous, right? So making your data continuous or exclusive is very much important before you start with the plotting of the histogram, right? So frequency we don't have to do much about here. It is all given properly only, right? So first important step here is to make these class intervals continuous or make them exclusive. Remember, whenever their data is inclusive, we should make it exclusive, right? This is the first step. And in the table itself, we are going to make that change. So this is known as class interval, this is known as frequency, and how we are going to change the class intervals is known as the actual class interval. Now I will tell you the method by which this discontinuous thing can be changed into continuous part. So students, the first step in making the discontinuous data to be continuous is see the difference with how much difference the both upper and the lower limit are having, how much of the difference. Okay, that how much the upper limit and the lower limit are having the difference, right? So that thing I will explain you how. Here it is 14, here it is 15, here it is 19, 20. So how much is the gap coming? Gap is coming that of 1, right? So we will now start the process of finding that adjustment factor. Adjustment factor, how it is calculated, that first of all we will find the difference. 15 minus 14 is equal to 1. Then we will take the half of that 1. So it means each difference is divided by 2. Each difference is divided by 2. It becomes 1 by 2. This 1, from where this 1 has come? This 1 was the difference in the upper and the lower limit. Okay, of the first one and the second one. Of the first one, like 29 to 30, how much is the gap coming? It is coming to be 1, right? So after dividing it by 2, we get the answer to be 0.5, right? So this 0.5 now is known as the adjustment factor. This 0.5 is known as the adjustment factor. So how we are going to adjust this 0.5? As, just see, this 0.5 will be adjusted in both the lower as well as the upper limit. From the lower limit, this 0.5 will be subtracted, and to the upper limit it will be added. Just see, the first class interval is 10 to 14, right? So how I have adjusted this? In the first 10, from the first 10 lower limit I have subtracted, so the answer is 9.5, and in the second, that is 14 upper limit, I have added 0.5, it becomes 14.5. So of this 10 to 14, the actual class interval now becomes 9.5 to 14.5. Okay, that adjustment factor we are going to adjust everywhere in order to make the data continuous, so that the second class interval will become 14.5. It was 15, subtracting 0.5 will give 14.5, and adding 19 plus 0.5 will give me 19.5. And see the change. Earlier it was discontinuous, now it is properly continuous only. We have done that process. Okay, now next one, 20 will become 19.5 and 24 will become 24.5. See again the change. These are very much continuous. Earlier they were not continuous, right? Now the next one will become 24.5 to 29.5, how we have done. Again, finally I am telling, from 25 we will subtract 0.5 and to 29 we will add 0.5. Okay, and the last one is from 30 to 34. Okay, so I will write it here as 29.5 to 34.5. Okay, so again the things till the last we find that the things have become continuous. So this is the process of adjusting the adjustment factor, making the inclusive data to be exclusive. Now students, once the data has been done continuous, you can very well start the exactly same process of plotting the histogram. Okay, exactly same method, exactly same process, we can plot the histogram. So that is all that I am not drawing, because already the exactly same thing I have explained to you just now. Okay, so that is all about the process of plotting the histograms, whether the data is continuous or discontinuous, right? That was the very important thing we will do in the statistics. Okay students, so that was all. If you like my video, please do press the like button. That is very much important. Okay, that will give a like motivation. Okay, and it will show your interest also. And please, if you are new, please do subscribe my channel. Okay, thank you very much for watching and stay tuned for my next videos. Thank you very much.